Hello students, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my YouTube channel. Before I begin today's video, I wish all my Muslim viewers and students a happy Eid Mubarak as I am recording this video on Eid Day. The time is now 1 p.m. I just prayed my Lohar and came home to record this film for you to teach a very important question in combined mathematics. So without talking too much, let's delve into the question. Right. Now, what question I'm going to discuss today is the question 11 in part A of Combined Mathematics paper 1. So, as usual, I'm not going to display the question. I will just read the question. Hope you might have your past papers with you. So, today I will record only this question as I have to celebrate my Eid also, right? So, as you all know, Muslims celebrate two Eids, right? The first one is Eid al-Fitr and the second one is Eid al-Adha. So after 29 days of fasting, we are celebrating Eid al-Fitr today, and I just visited some of my relatives in the morning, and I'm going to spend some time for you also. After that, I will go to some of my relatives in the after Asr prayer as well, right? So as I have to celebrate my Eid also, and I don't want to skip recording videos for you as well, so I just decided to spend 1 hour to record this video and for some editing work. So with that information, I will read the 11th question. A part, let P belongs to R and 0 less than P less than or equal 1, show that 1 is not a root of the equation p squared x plus 2x plus p is equal to 0. So they have given two conditions about p. I'm sorry. Right. They are telling p belongs to real number and 0 less than p less than or equal 1. Show that 1 is not a root of the equation p squared x squared plus 2x plus p is equal to 0. So we have to show that 1 is not a root of this equation. So root is the fancy way of saying the solutions, right? So root means that is a solution. So if I put 1 instead of x, the equation should be satisfied. So now showing that 1 is not a root of this equation is not possible because we cannot show that. So what I'm going to do is I'm going to take that 1, or I'm going to suppose, or I'm going to assume that 1 is a root of this equation. So if I substitute 1 in this equation, if the equation is not satisfied, I can tell 1 is not the root of this equation. So suppose, what I'm going to write is suppose suppose 1 is a root of this equation, right? Now by substituting x is equal to 1, we say p squared plus 2 plus p is equal to 0. Now if 1 is the root of this equation, this will become like this. But we already know p is greater than 0. P is greater than 0 and p lies between this region. So it cannot exceed than 1, but it is equal to 1. But p is not equal to 0, but p is greater than. So if I denote the value of p in a number line, this is 0, this is 1. So p is like this. Okay. So these values p can take. So if p is greater than 0, so if I put 0.1, so this will be 0.01 plus 2. So now since p is greater than 0, this cannot be possible. So this is impossible. This is impossible because at least p squared plus 2 plus p should be greater than 2, right? Because even if this is 0, it will become 0 plus 2 plus 0 will be 2. So 2 is not equal to 0, but this side should be greater than 2, right? Okay. So with that idea, we can tell 1 is not a root of this equation. Okay, right. Now continuously they are telling let alpha and beta, right, continuously they are telling let alpha and beta be the roots of this equation. Show that alpha and beta are both real. So what they are telling is now alpha comma beta are the roots of this equation. So we have already found out that one cannot be the root of this equation. So alpha and beta. So x can be x is equal to alpha or x is equal to beta. And we have to show that alpha and beta are both real. So this is a quadratic equation. A quadratic equation may have two solutions. So what we have to do is, so we have, right, so solution x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So this is the solution of x, right? So if we want to show that the solution is real, the discriminant part should be greater than 0. So we have to show that, then only it can have. So the discriminant is equal to b squared minus 4ac. So now b squared is equal to this one, 2 square. So 4 minus 4 into a is this one, p square, into c is p. So that is equal to 4 minus 4p cube. So that is equal to 4 into 1 minus p cube. Now, since, okay, now we have to show that this is greater than 0. Definitely this is greater than 0. So, what you have to write is, this is greater than 0. So, that's all what you have to write. But, what I am going to? I am going to reason out why this is greater than 0. 4 is always positive, right? Now, let's say, okay, now the p can take any value within this range only. So if this is 0.1, 0.1 cube will be 0.001, right? Yeah. Now if now this value, so when I okay, now 0.1, 0.2, 0.2, any value it can take, but it can take 1 also, right? So it can take 1 also. If it takes 1, now it will become 0, right? So it can be equal to 0 as well. It can be equal to 0 as well. Otherwise, it will be definitely equal to positive. It will be positive because if I subtract p cube from 1, it will be always positive, because when I cube p values, when I take cubic values of p, it will definitely less than 1. So it will be always greater than or equal to 0. So now the properties of discriminant, right? So delta greater than or equal to 0, greater than 0, it will have two real solutions, right? Then if delta is equal to 0, it will have one real solution, because the quadratic equation will have two solutions, but the 2 points will be the same. So it will have one real solutions. And if delta less than 0, it will not have no real solution. It will have imaginary solutions only, no real solution. So this is the features of delta. So from delta we can tell how many real solutions a quadratic equation will have. Right. Now we will move to the next part. Write down alpha plus beta and alpha beta in terms of p and show that they have given something below that. Okay. Now let me write down alpha plus beta and alpha beta here. So, okay. Now I erase this one and I want to write alpha plus beta and alpha beta. So alpha plus beta is equal to minus b over a. So that will be equal to minus b minus 2 over a is equal to p square. And we have to find out alpha beta also, that is equal to C over A. So C over in A means we are going to take a typical equation A squared, I'm sorry, AX squared plus BX plus C now is equal to 0. If the roots of these equations are alpha and beta, so x is equal to alpha and x is equal to beta. So let alpha and beta be the roots of this equation. Then we can say alpha beta is equal to C over A and alpha plus beta is equal to minus B over A. So if I apply these equations here, minus b is equal to minus 2, a is equal to here the coefficient of x squared, that is p squared. Again alpha beta is equal to c is here p over a is equal to p squared. Since p is not equal to 0, I can divide by p, right? So 1 over p, right? Now I have written alpha plus beta and alpha beta in terms of what? P, right? In terms of P. Okay. Now they are telling ensure that alpha into, I'm sorry, 1 minus 1 over alpha minus 1 into 1 over beta minus 1 is equal to p squared divided by p squared plus p plus 2. So I have to show this one. So I have to take LHS and show that is equal to RHS. Now take LHS. Take LHS which is equal to 1 over alpha minus 1 into 1 beta minus 1. Okay. Right, now this is very simple, right? So this is equal to, now I just want to multiply the denominators of these two fractions which are multiplied together. So 1 divided by alpha into alpha beta minus alpha plus beta, because this will become minus alpha and minus beta, minus taking out, then alpha plus beta plus 1. So that will be equal to 1. Now I have found out alpha beta and alpha plus beta here. So I just want to substitute those values. Okay. So here alpha beta is equal to 1 over p minus into this minus will become plus 2 over p squared plus 1. So just simplification remains. After writing this, you can directly write this one. What I'm going to take is, I'm going to take p squared as the LCM. So p squared, and going to bring this to the numerator of this fraction. So p squared. Then I have taken p squared as the LCM. So here p plus 2 plus p square. Okay, so I have just substituted, I have just multiplied the denominator by p square, and I have just so you can simply think like it. Both numerator and denominators are multiplied by p square. Then here we will have p square. Then this p square divided by p. So p square into 2 over p square, so p2 plus p square. So here we have obtained what we have to show. So ultimately you have to write p square over p square plus p plus 2. So this is also very simple. You don't need to spend much time on this. So now while you are studying, you have to understand and learn, but when you are writing an examination, you have to try to minimize the time so that you can utilize the rest of the time for the next questions. Okay. Right. Now show also that the quadratic equation whose roots are alpha over alpha minus 1 and beta over beta minus 1. Now we have to form the equation of show that the quadratic equation. Now we have to form a quadratic equation whose roots are given as alpha over alpha minus 1. So now we have to okay. I will erase this portion. Now we have to write down the quadratic equation. The roots are given of alpha over alpha minus 1, comma beta over beta minus 1. So for finding out the quadratic equation having the roots as alpha comma beta, so that is equal to x squared minus sum of roots into x plus product or multiple product of roots is equal to 0. So this is what I have to write. So I need this and this. So sum of roots is equal to this plus this. So I have to find out these two separately. Alpha over alpha minus 1 plus beta over beta minus 1 will give me. Now we have already found this also, right? So we have to keep that in mind as well. So what I can do is, so I can take the LCM, so alpha minus 1 into beta minus 1. Now alpha into beta minus 1 plus beta into alpha minus 1. So this will give me alpha beta minus alpha, again alpha beta, so we have 2 alpha beta minus alpha minus beta, so minus alpha plus beta. Since I have values for alpha plus beta and alpha beta, I have to transform them, right? Divided by alpha minus 1 into alpha beta minus 1. Okay, now this can be written as 1 into, this can be written as this can be written as okay, now this can be written as 1 into, now into 1 divided by alpha minus 1 into beta minus 1. Okay, because this is what I have already found out. So here this is equal to 2 alpha beta. 2 alpha beta is equal to 2 over p minus alpha plus beta minus, so minus into minus plus 2 over p squared into, here I have already found out this, so p into p squared plus p plus 2, right? Now since p is greater than 0, I can eliminate this and this. So what I have is 2 p plus 1 divided by p into 1 over p squared plus p plus 2. So I have 2p plus 1 divided by pq plus p squared plus 2p. Okay, so 2p plus 1 yeah, I have made a mistake in simplification. 2p 2p squared p squared. I'm sorry. Yeah, okay. So I have found out where I have made mistake, right? So this type of mistakes will ruin your life. So I don't know whether I'm deliberately making the mistakes or I'm carelessly making the mistakes, but this is a teaching for you. I want to teach you everything. A small mistake can ruin your life. So here you see, here I have put 2, but here I forgot to put 2. And this led me to get a wrong answer in this step. So what I should have done is, I should have put p squared here. I should have put p squared here, right? Now if I put p squared here, Right now, this p, everything is here, p square. And I'm going to write this here. Okay, that is equal to. I want to simplify this here. Okay. Now I just check the answer in the key. Then I realize that this answer is wrong because I made a mistake here. Now I will simplify correctly. Now what I'm going to do is 2 plus 2 over p plus 2 over p square, and here we have p square. Okay. Now Now I'm going to take p square as the p square. Now p square, if I take p square, now this will become 2p plus 2 into p square divided by p square plus p plus 2. Now p square will go. Now I can take 2 out, p plus 1 divided by p square plus p plus 2. Now this is the sum of roots. Now I have to find out product of roots. Product of root mean that is simply alpha over alpha minus 1. Alpha over alpha minus 1 into beta over beta minus 1. This is what I have to find out. So this will be equal to alpha beta into 1 over alpha minus 1 beta minus 1. Now I have this also, right? Alpha beta is equal to 1 over p. 1 over p into p squared over p squared plus p plus 2. Okay, so I can eliminate this and this. So I get p divided by p squared plus p plus 2. So this and this are going to be substituted in this equation. So I will get the quadratic equation having the roots as alpha divided by alpha minus 1 and beta divided by beta minus 1 is x squared minus this sum, 2 p plus 1 divided by p squared plus p plus 2 x plus p divided by p squared plus p plus 2 is equal to 0. Now I can simplify it further, but that doesn't matter. You can leave at this point as well. So I will check the answer in the at this point you can leave. Okay, you don't need to simplify it. Okay, right. Now we will move to the B part. So far we have discussed the A part of the question, and we will move to the B part. Let C and D be two non-zero real numbers, and let f of x is equal to. So f of x is given.